Hello everyone. Today we are gonna solve Feb March 24 QP62, that is ATP. So let's start with first question. Calcium carbonate is an insoluble solid. Calcium carbonate can be made by adding excess aqueous calcium chloride to aqueous sodium carbonate. They have also given us the chemical equation. A student makes a sample of calcium carbonate. The first two steps of method are shown. So they have given a diagrammatic representation of how they are adding both the compounds together. Okay, and in step 2 they are mixing it. Name the item of apparatus labeled A. A is stirrer. Okay, so you can write stirring rod or glass rod. B, suggest why the mixture is stirred in step 2. So it is simple, it is being mixed or it is being stirred so that the substances can mix together. To mix the substances together. After step 2, the student filters the mixture to remove the solid calcium carbonate formed and collect the filtrate. Draw label diagram to show the apparatus used for this filtration. So for filtration, we need to show a filter funnel and a conical flask. Okay, so we are first gonna draw the filter funnel. Okay, it is lined with a filter paper, and here you can show some kind of solid. Okay, and then you have your conical flask with the filtrate. Okay, so this is your filter paper, this is your solid calcium carbonate, and this is filtrate. D, the solid calcium carbonate is obtained by filtration is not pure. Identify one substance other than water which is mixed with calcium carbonate and makes it impure. Okay, so this is a precipitation reaction. When you filter it, you get the residue. Okay, so there can be traces of any of the compounds from which it is being made. So you can write any of the reactant used to make calcium carbonate. So it can be either calcium chloride or sodium chloride. So I'm writing calcium chloride. Any one of this is correct. Next, describe how the substance you have identified in D1 can be removed from the calcium carbonate. So to remove the traces of any of these reactants, we can rinse it with water. Okay, so we can pour water over the residue. Pour water over the residue. Next, E. Describe a test the student can do on the filtrate obtained in C to show that the calcium carbonate chloride used is in excess. Give the result student obtains if the calcium chloride is in excess. So we have to tell that whether the calcium chloride is in excess or not. Okay, so that we can do by adding NaOH. Okay, if we add aqueous NaOH in calcium chloride, it is gonna form a white precipitate which is calcium hydroxide. We can filter and we will get the residue of calcium hydroxide. Okay, so we can add aqueous NaOH, okay, to test, and it is gonna give us white precipitate. Next, Question 2. A student investigates the reaction between aqueous sodium carbonate and two different solutions of dilute hydrochloric acid, label A and B. So we have two different solutions of HCl, that is A and B. There are in total 3 experiments of titration being performed here. So for the first experiment, rinse a burette with distilled water and then with dilute hydrochloric acid. Rinse a conical flask with distilled water. Fill the burette with dilute acid A. Run some of the dilute hydrochloric acid out of the burette so that the level of dilute hydrochloric acid is on burette scale. Record the initial burette reading. Use a measuring cylinder to pour 25 centimeters cube of aqueous sodium carbonate into the flask. Add few drops of methyl orange indicator. Slowly add dilute hydrochloric acid A from burette to conical flask while swirling the flask until the solution becomes orange. Record the final burette reading. So the whole procedure is repeated in experiment 2, but if you read the experiment, instead of methyl orange they have changed the indicator to thymol phthalate. Okay, rest procedure remains same. And in the third experiment they have again repeated experiment 1, but this time instead of using dilute hydrochloric solution A, they have used dilute hydrochloric solution B. Okay, now first question, they have given us the burette readings here of the final and initial burette readings. We are supposed to note it down in this table. So for the first experiment, the final reading is 12.9. For the second one, the final reading, oh sorry, it is for the second one. Okay, for the first experiment the final reading is 26.2. For second experiment it is 12.9. For the third one it is 39.1. Initial reading for experiment 1 is 0.8. For the second experiment it is 0.2. For the third experiment it is 1.0. Now you have to subtract the final reading minus initial reading. So for the first experiment the difference you will get is 25.4. For second it is 12.7, and for the third experiment it is 38.1. This is very scoring. This table is for 4 marks. You just have to look at the values and note it down in the table. B1. State which solution of dilute hydrochloric acid A or B is more concentrated. So for that again we will have to refer the table here. If you see, for experiment 1 they have used solution A. For experiment 2 also they have used solution A, and for experiment 3 they have used solution B. Now for difference between solution A and B, which one is more concentrated? The one where less volume is required, it is more concentrated. So if you consider solution A and solution B, okay, solution A required is very less as compared to solution B. So the more concentrated solution is solution A, and it is because less volume of A is required. Okay, yeah, next one. Deduce how many times more concentrated the solution of dilute hydrochloric acid is than the other solution of dilute hydrochloric acid. Okay, so here we have to compare that how much these two solution A and solution B are different from each other. Okay, how much times they are different. So we are supposed to divide the values 38.1 by 25.4. So 38.1 divided by 25.4 is gonna give me 1.5. So it is 1.5 times more dilute. Next, compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A used in experiment 2. Okay, so as we know that experiment 1 and 2, in both the cases they have used solution A. Okay, but you see that the values we get, the final values of hydrochloric acid required is totally different, because the indicators used in both the experiment 1 and 2 is also different. So we have to compare here. Okay, so if you see, experiment 1 requires a greater volume of solution A than experiment 2. Okay, and how many times it is greater again, so that we will write. So first of all, we require greater volume of solution A in experiment 1. Okay, and it is twice. Okay, so it is 25.4 divided by 12.7, which is going to give you 2. Okay, so it is twice as much as more required. Okay, next question. Deduce the volume of dilute hydrochloric acid B required to reach the end point if experiment 3 is repeated using thymolphthalin indicator instead of methyl orange indicator. Now here they are asking us that if we change the indicator, so what will be the expected volume of hydrochloric acid required. Now if you read the experiment 1 was done with methyl orange. Okay, experiment 2 was done with thymolphthalin, and experiment 3 was again done with methyl orange. Now they are asking, instead of methyl orange, if we are repeating experiment 3 with thymolphthalin, what will be the value. Now in the above question C1, we have identified that the volume of solution A, or the volume of the volume of solution A was concentrated twice, that is 2 times. So the value of experiment 3 that we have got, which is 38.1, if we divide it by 2, we get the value 19.05. So 19.05 centimeters cube of hydrochloric acid B will be required if we use thymolphthalin as an indicator. Next, D. At start of experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid B. So first it is rinsed with distilled water and then with dilute HClB. Okay. Identify the substance removed from the burette when it is rinsed with distilled water at the start of experiment 3. So experiment 1 and 2 were actually done using solution A, and experiment 3 is done with solution B. Okay, so we are trying to remove dilute HCl Next question. Describe how the result of titration would change if the burette was not rinsed with dilute hydrochloric acid B after it had been rinsed with water. So if the burette is only rinsed with water and if we start the titration, we will require large volume of acid. So large volume of acid will be required. Third, explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water. So if we are not rinsing it with aqueous sodium carbonate, okay, when we rinse it with water, again there will be more volume of aqueous sodium carbonate would be required. Next, Explain why a white tile is used during the titration. It is very simple to see the color change clearly. To see color change clearly. F. Describe the effect on the result of warming aqueous sodium carbonate in experiment 1 before carrying out titration. Explain your answer. So there will be actually no change, okay, even if we warm aqueous sodium carbonate when we are performing titration. So the effect will be none, okay, and the explanation will be warming does not show any effect on the moles or concentration or volume of the compound, okay. So the concentration or volume will not change. Next, question 3. A student tests two substances, solid C and solid D. Solid C is ammonium iodide. So we already know the compound, okay. Now, to the first portion of solution C, the student adds 1 centimeter cube of dilute nitric acid followed by few drops of aqueous barium nitrate. So here dilute nitric acid and barium nitrate test is done. So this test is actually done for, here if you see, we have dilute nitric acid and barium nitrate. This test is done for sulfate ions, whereas our compound does not contain any sulfate ions, okay. So there will be no change. B. To the second portion of solution, the student adds 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. Now, as we have done in the previous question or the previous video, that silver nitrate test is for halogens, okay. If you see the compound, we have a halogen present in it, which is iodide. So the color change here is yellow precipitate. C1. To the third portion of solution C, the student adds an excess of aqueous sodium hydroxide. Now, our compound is ammonium iodide. Okay, so ammonium is a cation, and if we check that if we add sodium hydroxide in ammonium ion, ammonia produced on warming, but in that question they have just added sodium hydroxide, and on adding sodium hydroxide there is no specific change, so it will be no change here, okay. And in the next question, they warm the product from C1 and test any gas given off. So here the gas given off was ammonia, and we need to write the observation of ammonia gas which is tested. So it is damp red litmus paper turns blue. Next, test on solid D. So we have to identify solid D here, okay. So they have performed a flame test and we are getting yellow colored flame, okay. So here we'll just check that yellow color flame is of which element, and it is for sodium, okay. So we identify our cation as sodium with the help of flame test. In the next question, gently heat about half of the remaining solid D. Steam is given off and condensation forms on top of the boiling tube. Hold a strip of anhydrous cobalt chloride paper at mouth of the boiling tube. The anhydrous cobalt chloride paper changes color, meaning steam given off, it is clearly mentioned that it is water or the salt is hydrated, okay. Test 3. To the first portion of solution D, add aqueous ammonia dropwise until in excess. Green precipitate is formed which is insoluble in excess. So we'll just check that which cation gives us green precipitate. So we have both chromium and iron which gives us green precipitate, but it is insoluble in excess. So we confirm the cation as iron here, okay. So In test 3, I confirm it as iron. In test 4, to the second portion of solution D, add a piece of aluminium foil and a 5 centimeter cube of aqueous sodium hydroxide. The observation is green precipitate. Heat the mixture formed and hold damp red litmus paper on the mouth of the boiling tube. The damp red litmus paper remains red. So actually the test that of aluminium foil and sodium hydroxide is done for nitrate ions. Okay, so if you check that here in nitrate, sodium, aqueous sodium hydroxide and aluminium foil on warming, okay, it gives us ammonia. So the observation should be damp red litmus paper turns blue, but actually here the damp red litmus paper remains red, okay, meaning it is a negative test for nitrate ions. For test 5, to the third portion of solution D, add about 5 centimeter cube of dilute nitric acid. Effervescence is shown. Bubble any gas formed through lime water. The lime water turns milky. Lime water turns milky is the specific test for carbon dioxide gas. Okay, meaning carbon dioxide is released. So there can be only one anion that releases carbon dioxide, which is carbonate, CO3 2 minus. Okay, so this is what we are able to interpret from the given tests and observations. Now we'll move towards the questions. State the final color of cobalt chloride paper in test 2. So the anhydrous cobalt chloride paper changes the color. Anhydrous cobalt chloride is blue in color, and when it comes in contact with water, the color will change to pink. Next, state what ion observations in test 4 shown is not present. So in test 4, as I told you, that the red litmus paper remains red, and this test was performed for nitrate ions. So nitrate ions are absent here. Identify the gas produced in test 5. We have already identified that the gas produced is carbon dioxide. Identify the 3 ions in solid D. So here the 3 ions, with the help of flame test we have got sodium, with another test we have got ion, and in the last test we have concluded that it is carbonate. So the 3 ions that we have is Na plus, then Fe2 plus and CO3 2 minus. So it is not necessary that always the solid will be only one compound that will contain one anion and one cation. It can be mixture of solids, and you might get different cations and anions in that. Question 4. When excess dilute sulfuric acid is added to solid zinc, hydrogen gas and aqueous zinc sulfate are made. Equation is also given to you. Plan an experiment to show that copper is a catalyst for this reaction. Your plan should include how the results of experiment will show that copper is catalyst for this reaction. You are provided with zinc powder, dilute sulfuric acid, copper powder, and common laboratory apparatus. If you read the question properly, you see that they have already given you the chemical equation. They have told you that what are the products formed. Okay, they want you to find out that whether copper is acting as a catalyst or not for this reaction. So in this case, how are we gonna write the answer? So you will have to mention the amount of solids used, that is how much amount of zinc you have used, how much amount of sulfuric acid you have used, okay, and how are you gonna perform this reaction. So because hydrogen gas is released, we can use gas syringe to collect hydrogen gas, okay, and we can note down the time required to collect the gas or for completion of the reaction. Once again we can repeat this reaction, but this time we can add copper in that, and we can again record the time required for the reaction to complete, after which we can compare the time taken for completion of reaction without copper and with copper. Okay, this will help us to understand whether copper is acting as a catalyst or not. Also, if copper does not take part in the reaction, then also copper is acting as a catalyst. So we'll just write the points required. Okay, so the first point that you can write here is measure known volume of dilute sulfuric acid. Then you have to weigh known mass of zinc. Then add both in conical flask attached with a gas syringe. Collect hydrogen gas in syringe. Then repeat the reaction with known mass of copper. So once you repeat the experiment, so what will be the conclusion here? Okay, so after completion of reaction, filter and dry and weigh the copper. If the time taken for reaction to complete is less and mass of copper does not change, then copper acts as catalyst. Okay, so these are the points that you need to explain here, how you have performed the experiment. Okay, and how the method which you have chose is gonna help you to find out the question that they have asked. How the method you have used is helpful for you to find out the question they have asked you. Okay, so here as they asked us that we have to find out whether copper is acting as a catalyst or not, so we performed the reaction first without copper and then we performed it with copper, and we already know that what can be the results when we add a catalyst in a reaction. Okay, so it should speed up the rate of reaction and also it should be unchanged because it does not participate in the reaction. So while writing plan and investigation, you need to write down any measurements if required, any suitable apparatus where you need to perform the experiment. Like here I have mentioned conical flask where the reaction needs to be performed, and gas syringe where the gas is needs to be collected. Okay, and final is the conclusion that how the method which I have written is gonna help me to identify whether copper is acting as a catalyst or not. Hope you have understood whatever we have solved in this paper.